Hi everyone, hope you're doing well, and I hope that you have all the resources that you feel like you've needed for reviewing this organic chemistry nomenclature. In this video, I'm going to be going over pages 3 and 4 of your practice. Remember that in the review packet that I gave you, all the answers were included on page 3, so we're just going to go over pages 3 and 4 in this video. Look for an assessment to come out on Google Classroom sometime later today. I'd like you to finish that by the end of Thursday. So starting with number 1 here, it says hydrocarbons that contain single bonds, single covalent bonds, are called, and this is the difference that we talked about between alkanes, which are single bonds, alkenes and alkynes. And so that's one thing you can look for to determine the difference. What is a saturated hydrocarbon? This is one that I covered in class. If a carbon has the maximum number, the hydrocarbon has a maximum number of hydrogens, then it's saturated. So an example would be like butane. We have 4 carbons, and they each have their maximum number of hydrogens. Like so. And I'll bring up an example of an unsaturated once we get to it. So, speaking of butane, that was a good choice because that's our next compound here. Just going to drag that here. Butane would be an example of a saturated compound. Now let's look at 2-pentene. Remember those prefixes, methyl, ethyl, propyl, butyl, pentyl. That's 4 carbons. 5 carbons. And on the second carbon, we'd expect to see a double bond, which is indicated by the ENE. So I'm adding my double bond there, adding my hydrogens in. Got 3 on this end carbon, 2 on this carbon, 3 on this end carbon. And since these 2 carbons have 3 valence electrons that are bonded, they only have 1 valence electron that is available to bond with hydrogen. This example here, because of this double bond, this would be an example of an unsaturated hydrocarbon. Really what you're looking for is a double or triple bond, and that tells you that it's unsaturated. Okay. Next one. Hexane. Well, hexane is 6 carbons. So hexane, there's going to be a triple bond in there somewhere. And it's on the 3rd carbon. So 1, 2, 3rd carbon here. And then we just add our hydrogens in. I had mentioned in class that it actually does matter which side you put the hydrogens on when it comes to that double bond. It's the difference of 2 different kinds of isomers. But we're not getting into that any further than just the example I gave you in class with thalidomide. There we go. Alright, 1,3-hepta, so we have 7 carbons. Now I'm going to show you a little shortcut on doing these hydrocarbons now. In organic chemistry, sometimes you start to see zigzags. And we basically ignore the hydrogens and we're only showing the carbons. So 1, 2, 3, 4, 5, 6, and 7. 7 carbons there. On our 1st and 3rd carbon, we're expecting to see double bonds. So 1st carbon to 2nd and 3rd carbon to 4th. That is 1,3-heptadiene. Notice that di fits in there. Now let's practice our naming. Well, let's number these. 1, 2, 3, 4. Notice if I would have reversed that, our double bond still would have been on the second carbon. So it doesn't make any difference. Now, under normal circumstances, this would be butane, but we have a double bond, so it's going to be butene. And what carbon is that double bond on? It's the second carbon, so we call it 2-butene. In the next example, we've got 1, 2, 3, 4, 5, 6 carbons. I'm going to start from this side because that is the side that is closest to the triple bond. Now this would normally be called hexane, but because there's triple bonds, I'm going to call this hexadiene. The di indicates that we have two double bonds, or excuse me, triple bonds. And what carbons are those triple bonds on? Well, it looks like we're on the first carbon and the fourth carbon. We count the first carbon that comes to the double or triple bond. So this would be 1, 4. Normally hexane, but it's hexine because of the triple bond, and di because there's two triple bonds. 1,4-hexadiene. It says, what is incorrect about 3-pentyne? If we were to draw pentyne, 1, 2, 3, 4, 5 carbons, and on our third carbon, we're expecting to see a triple bond. So 1, 2, 3, it'd be like that. Something seems wrong about this because our triple bond, all right, now it's a triple bond. Our triple bond is pretty far over to that right-hand side. Wouldn't it make sense to start counting from this side? In that case, we would call this 2-pentyne. It would actually be impossible to have 3-pentyne because the triple bond necessarily would be further away from the initial carbon, making the name change. And so we'd call it 2-pentyne. Okay. Let's see. All right, so initially when I see these names, the first thing I'm looking at, the first thing you should be looking at is what is the basis for this molecule? And the hex right there implies that we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 carbons. We know that we're going to have a double bond, and that double bond is coming from the first carbon. We have a methyl group on the second carbon, and we have 2 ethyl groups on the third and fourth. 1, 2, 3, 4. So that's our molecule. Now on to this next one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 7, and that's because we have hept, and that ine there is going to show up on the second carbon. That's a triple bond. On the fifth and sixth carbons, we're going to have methyls. 1, 2, 3, 4, 5, and 6. Like that. This is a formatting mistake, but I think we can make it work. Let's say it was right there. It actually wouldn't matter for this molecule. The longest carbon chain is going to be this one here. And I'm going to start counting from this side because that's what's going to get us to the branch first. So 3-methyl. And we have 1, 2, 3, 4, 5 carbons total. So pentane, because there's no double bonds. And then this next one here, I'm just going to call it like that. when we go to number this one, we're going to start from this side because we have our double bond closest to that side, and that takes priority over our branch. So since we have a branch, we'll start with that. It's a 5-methyl branch. And on our second carbon, we have our double bond. And since we have 6 carbons, normally this would be hexane, but it's a hexene because of the double bond. Okay, just going to add that one there. In this one, we're going to start counting from the left-hand side. Our second carbon has the triple bond, so we're going to call this 2. Normally hexane, but this will be hexyne because that triple bond shows up on the second carbon. All right, number 8, probably a tough one for some of you. Isomers, I did kind of mention it in class, but this will be a little less review and more just kind of learning here. Octane would normally be 1, 2, 3, 4, 5, 6, 7, 8. It would look like this with 8 carbons. I'm going to give you an example of one octane, and that would be with saturated hydrogens. Each of the carbons having its maximum amount of hydrogens. And that would be C8H18. If you don't believe me, you can count the hydrogens up. That would be octane there. Now, isomers, there's different types of isomers, but I've talked about isomers as in the same formula with a different structure. What if we had you can count these carbons up. There's 1, 2, 3, 4, 5, 6, 7, 8 carbons again. And if we were to draw our hydrogens, what you'd find is that there's actually 18 hydrogens once again. That's because this is an isomer of octane. Has the same formula, overall formula, but obviously it's going to have different properties and a different name at that. It's not going to be octane anymore. It's going to be, looks like 2-methyl heptane. But anyway, the formula is the same, C8H18. So it's an isomer, different structure, same formula. One other one. What if we had an ethyl group coming off here? 1, 2, 3, 4, 5, 6, 7, 8 carbons, and I will let you verify that there's going to be 18 hydrogens. Now all 3 of these are going to be saturated. If we start throwing in double or triple bonds, there won't be 18 hydrogens because it will no longer be saturated. So all of these saturated hydrocarbons. That's it for the material that you'll be assessed on. Look for that to come out sometime in the next, say, 24 hours.